Welcome to the Deep Dive, where we break down complex tech and strategy for you. So today, we're looking at a big challenge for B2B businesses, making the most of platforms like LinkedIn for marketing. It's powerful, sure, but wow, it can be a real manual slog, right? That's exactly why we're diving into this blueprint for an intelligent B2B marketing SaaS platform. It's built on AWS, and the source material we've got is incredibly detailed. It's not just about copying LinkedIn marketing solutions. It's about taking it, well, several steps further with AI. Our mission today, to really unpack how this thing could offer a shortcut to smarter, automated B2B marketing, making the complicated stuff feel, well, maybe not easy, but definitely more intuitive. And yeah, there are some surprising tech choices under the hood we need to talk about.
Absolutely. What we're looking at here, it's not just, another marketing tool with a bit more automation. This architecture suggests a pretty significant leap. Think real automation, real intelligence, changing how you'd approach B2B campaigns, less grunt work, more strategy.
Okay, let's get into it then. Intelligent gets thrown around a lot. What makes this specific platform genuinely different, beyond just like scheduling posts or something basic we already have?
That's the key question. The real differentiator, the core innovation, is this multi-agent architecture. It's powered by an open source framework called CrewAI.
CrewAI. Okay, tell me more.
Yeah, so CrewAI is a Python framework. It lets you build and orchestrate these autonomous AI agents that have specific roles and can collaborate on complex tasks. Think of it like having a virtual marketing team inside the software. Now, contrast that with your typical microservices. They often have business logic hard-coded, right? They follow set rules. This CrewAI approach is different. It can automate really nuanced, multi-step workflows, things like devising a full campaign strategy or researching the perfect audience or even generating ad creatives. Because the agents collaborate, the system becomes adaptive. It learns, adjusts. It's much more dynamic than just hard-coded logic.
Ah, okay. So it's less like a dumb tool following orders and more like an intelligent assistant or maybe even a team that you're directing. That's the aha moment.
Exactly. You give it the goal, it figures out the how with its specialized AI crew.
Right. So for me, the marketer using this platform, what does that actually mean day to day? What are the core things this MVP version can do?
Okay, functionally, the MVP aims to cover the essentials you'd expect, but powered by that AI collaboration. So first up, campaign management. You can create campaigns, edit them, pause, archive, the usual stuff. But critically, you set the objective brand awareness, website visits, lead gen engagement, and the system uses that to guide the AI strategy.
Makes sense. Starting point.
Then there's the audience targeting. And this is where it gets pretty deep. You can target based on company details, industry, size, you name it. Demographics, of course, age, gender, but also really granular job experience, titles, functions, seniority levels, education background, even interests and traits drawn from things like LinkedIn groups or listed skills.
Wow, okay. That's specific.
It is, and it goes further. It supports matched audiences, where you upload your own lists, securely, of course, and predictive audiences, sometimes called lookalikes. The AI analyzes your best customers and finds other LinkedIn users who share similar characteristics. That's super powerful for finding new, relevant leads.
Yeah, lookalikes are huge. What about the ads themselves?
Right. Ad creative management. It needs to handle various formats because B2B isn't one size fits all. So sponsored content, your standard image ads, video ads, carousel ads, then message ads, those direct personalized messages, what used to be sponsored in mail. Also dynamic ads, which can pull in user info for personalization, and document ads for sharing things like white papers or case studies directly in the feed.
Okay, covering the main formats.
Exactly. And naturally, you need analytics and reporting. So a comprehensive dashboard showing all the key metrics, impressions, clicks, CTR, CPL, conversions, plus, importantly, insights into the demographics of who's actually engaging with your ads.
So you can see if you're hitting the right people.
Precisely. And finally, full budget and bidding control. You manage your daily or lifetime spend, and the system helps you participate effectively in the LinkedIn ad auction.
Okay, that sounds like a really solid foundation. It's got the features marketers need, but with that AI layer, hopefully making it smarter and faster. Now, you mentioned this crew of AI agents. This is where it gets really interesting for me. How does this intelligent assistant part actually work? Who's on the team? Let's meet the crew.
Yeah, this is the fun part. The marketing crew is the heart of it. It's a team of specialized AI agents designed using CrewAI. Each agent has a specific role, a goal, and even a sort of backstory or persona that defines how it approaches tasks.
Like a little AI specialist.
Exactly. So first, you've got the campaign strategist agent. Think of this one as your expert marketing strategist. Its goal is to take your high-level objective and devise a comprehensive LinkedIn campaign strategy. Then there's the audience research agent. This is your LinkedIn audience specialist. Its whole job is digging into LinkedIn data to identify the absolute best target audience based on the strategy.
Okay, strategy then audience.
Next comes the ad creative agent.
Mhm.
This is your creative whiz, part copywriter, part art director. It takes the strategy and audience info and generates compelling ad copy, suggests visual concepts, that sort of thing.
So it writes the ads.
It generates drafts and ideas, yeah. Then, crucially, you have the LinkedIn API agent. This one's the techie. It's the technical API integrator. Its role is to translate the plan into actual API calls and interact directly with the LinkedIn marketing API to, create the campaign, set the targeting, upload the creative.
A doer.
The doer, exactly. And finally, the performance analyst agent, your data analytics expert. This agent constantly monitors how the campaigns are doing, looks at the metrics, and identifies insights for optimization. It might suggest tweaks to the strategy, audience, or creative based on real-time data.
A whole team working together.
That's the idea. And they accomplish their goals using tasks and tools. A task is a specific assignment, like strategy definition task for the strategist or audience creation task for the researcher.
Right.
And tools are basically functions the agents can use.
Mm-hmm.
Many of these are custom Python functions that wrap specific LinkedIn API calls, like a create LinkedIn campaign tool or a get linked analytics tool. But they can also use more generic tools, maybe like a Serper dev tool for doing web searches if the strategist needs broader market context.
Okay, so walk me through it. Let's say I put in a simple request, like get me leads for our new cybersecurity software, target IT managers in the US. How does the crew handle that?
Great example. So you input that goal. First, it hits the campaign strategist agent and analyzes get leads, cybersecurity software, IT managers US. It decides the objective is lead generation, outlines the best campaign type, maybe suggests some initial messaging angles.
Okay.
That plan then goes to the audience research agent. It uses its tools, maybe querying LinkedIn data via the API agent to find the specific targeting criteria for IT managers in the US. Job titles, relevant skills, maybe company sizes or industries known to buy cybersecurity. It compiles that precise audience definition. Next, the ad creative agent gets the strategy and the audience profile. It generates ad copy tailored to IT managers, highlighting benefits relevant to cybersecurity needs. It might suggest image or video concepts.
Tailored content.
Exactly. Finally, all of this strategy, the audience parameters, the creative elements gets handed off to the LinkedIn API agent. It takes these structured pieces of information and uses its specific API tools to actually build the campaign inside LinkedIn, set the budget, launch it. The performance analyst then starts watching.
Wow. Okay, that automates a ton of complex steps. Research, writing, setup, all orchestrated.
That's the power of the multi-agent approach. It handles that complexity.
But building something that complex, especially for potentially thousands of customers in a SaaS model, that sounds like a huge infrastructure challenge. How do you make it reliable, secure? How does it scale? What's under the hood architecturally?
You're right. The infrastructure is absolutely critical. The blueprint outlines a really robust AWS setup. They use a hybrid compute strategy, which is quite clever.
Hybrid.
Meaning they use different compute services for different jobs. For the main marketing crew service, the one running those potentially long collaborative CrewAI agent workflows, they use Amazon ECS with AWS Fargate.
Why Fargate specifically?
Because these CrewAI processes can be long-running, an agent might need to research, then wait for another agent, then act again. This can easily exceed the 15-minute limit you get with, say, AWS Lambda. Fargate is container orchestration without managing servers, perfect for these stateful, potentially lengthy tasks. It provides a consistent environment.
Okay, so Fargate for the AI crew's heavy thinking. What about Lambda then?
Lambda is still used, but for the other microservices. Things like the tenant management service or the authentication service, these tend to be stateless, event-driven, and need to execute quickly. Lambda is super cost-effective and scales automatically for those kinds of tasks.
Right tool for the job. Makes sense. What about storing all the data? Campaign details, user info, logs?
Also a hybrid approach for data storage, matching the database to the data type. For structured, relational data, think tenant info, campaign configurations, things where you need transactional integrity. They use Amazon Aurora, the PostgreSQL compatible version. It's high performance, highly available, auto-scaling, great relational database.
Standard choice for structured data.
Pretty much. But for data that needs really high throughput, maybe less structured, like session state information or activity logs, they use Amazon DynamoDB. It's a NoSQL key value store. Gives you super low latency, massive scale, serverless, ideal for that kind of high-velocity data.
Okay, Aurora for structure, DynamoDB for speed and scale. Now, the big one for SaaS, keeping customer data separate. How to guarantee tenant isolation, especially if multiple tenants might be sharing the same database instance?
Huge point. The blueprint tackles this very directly. At the database level, they use what's often called a pool model, meaning tenants share infrastructure, but with strict logical separation. For Aurora, PostgreSQL, the key is row-level security, or RLS.
RLS, how does that work?
Think of it like database rules. You define policies on the tables, typically based on a tenanted column. When a user connects, authenticated via their JWT, which contains their tenanted, the database automatically filters every query they run. It adds a where tenanted use current tenant condition behind the scenes. So even if the application code had a bug, the database itself prevents tenant A from ever seeing tenant B's data. It's a powerful safeguard.
Okay, that sounds robust for Aurora. What about DynamoDB? It doesn't have RLS in the same way.
Correct. For DynamoDB, they also use a pool model, typically with a single table design. Tenant isolation is achieved through careful key design and IAM policies. Partition keys are prefixed with the tenant ID, something like tenant123 attached tag user 456. Then they use fine-grained IAM policies with the dynamod.leading keys condition. This IAM condition allows you to restrict access so that the application role for tenant123 can only read or write items where the partition key starts with tenant123 attached tag. It effectively scopes access down to only that tenant's data within the shared table.
Clever. Using IAM as the enforcer for DynamoDB. Okay, what about the network and overall identity management?
Security is layered, naturally. They propose a multi-VPC setup, separate virtual private clouds for production and management, linked securely via AWS Transit Gateway. This gives strong network segmentation.
Good practice.
For managing permissions within AWS, they lean on IAM with attribute-based access control, or ABAC. This is really important for SaaS scalability. Instead of creating a unique IAM role for every single tenant, which becomes unmanageable fast, you use a more generic role. But when the application assumes that role, it passes session tags, like the tenanted. Then IAM policies can use these tags to grant access dynamically. For instance, a policy might allow access to an S3 bucket only if the resource tag matches the tenanted session tag. It's much more scalable.
ABAC, right? Scales better than role explosion. And user logins.
AWS Cognito is the cornerstone there. The blueprint specifically recommends the user pool per tenant model. Each tenant gets their own isolated user directory within Cognito. This provides the highest level of isolation, allows for tenant-specific branding or security settings, and makes things like federating with the tenant's own identity provider much simpler.
Okay, that's a really solid, secure, and scalable AWS foundation. Quite the architecture deep dive. But, a great blueprint is one thing. How do you actually build this, connect it to LinkedIn, manage updates, and just run it smoothly every day? What are the operational pieces?
Yeah, the DevOps and operational side is just as critical.
Yeah.
First, that LinkedIn integration. It uses the standard, secure OAuth 2.0 flow. When a new tenant signs up, they go through a process to grant the platform permission to manage their LinkedIn campaigns on their behalf.
Standard authorization flow.
Exactly, and those sensitive access tokens and refresh tokens that LinkedIn provides, they absolutely must be stored securely. The blueprint calls for using AWS Secrets Manager for that. And those CrewAI tools we talked about, the LinkedIn API agent uses tools that securely retrieve these tokens from Secrets Manager to make authorized API calls.
Secure token handling? Check. How about managing all that AWS infrastructure itself? You mentioned ECS, Lambda, Aurora, DynamoDB, VPCs.
Yeah.
That's a lot to set up and keep consistent.
Definitely. This is where infrastructure as code, or IaC, is essential. The blueprint specifies using Terraform.
Terraform, interesting. Why not AWS CloudFormation, which is AWS native?
Good question. The rationale highlighted is cloud agnosticism. While it's built on AWS now, using Terraform keeps options open. Maybe someday they want to deploy a small part of the service on Azure or GCP for a specific customer need, or adopt a multi-cloud strategy. Terraform makes that much easier than being locked into CloudFormation. Plus, many find Terraform's language, HCL, more readable, and its modularity easier to manage for complex setups.
Future-proofing, basically. Okay. What about deploying code updates, especially for that core CrewAI service?
That's where CI/CD comes in continuous integration and continuous deployment. They leverage the AWS Developer Tools Suite, code commit for source control, code build to compile code and build Docker images for the Fargate service, code pipeline to orchestrate the workflow, and code deploy to push the new versions out safely, perhaps using blue-green deployments. It means developers commit code and automation takes it through testing and into production reliably.
Streamlined deployments.
Yep.
Nice. You mentioned tenants signing up. That onboarding and eventually offboarding sounds complex too.
It is. Manually setting up a new tenant, creating database entries, the Cognito user pool, linking billing would be slow and error-prone. So they use AWS step functions for automated tenant lifecycle management. Step functions are great for orchestrating multi-step workflows with built-in error handling and retries. You define the onboarding process as a state machine, and step functions executes it reliably every time. Same for offboarding, deactivating accounts, handling data attention policies, cleaning up resources automatically.
Automation is key for SaaS scaling. Got it. How do you monitor this complex system, especially knowing which tenant is causing load or experiencing issues?
Tenant-aware monitoring and logging. Absolutely critical in a multi-tenant system. You can't just have generic logs or metrics. The key is to enrich everything with context, specifically the tenanted and usually a unique requested. So logs sent to CloudWatch logs are structured, like JSON, and include these IDs. Custom metrics published to CloudWatch have tenanted as a dimension. Distributed traces captured by AWS X-Ray are annotated with the tenanted.
So you can filter and slice data per tenant.
Exactly. It lets you quickly diagnose if a specific tenant is having problems, or if one tenant, a noisy neighbor, is consuming way more resources than others, potentially impacting performance for everyone else. You need that visibility.
Makes perfect sense. And related to noisy neighbors, how do you figure out how much each tenant costs you to run, especially for shared resources like databases or the Fargate cluster?
Yeah, cost allocation is a classic SaaS challenge. The blueprint suggests a hybrid approach. For any resources that are dedicated per tenant, like maybe those Cognito user pools or specific S3 buckets if they use silos, you can use AWS cost allocation tags directly. Easy enough.
Right.
But for shared resources, the pooled Aurora database, the shared Fargate cluster, the underlying LLM cost for the AI agents direct tagging doesn't work. So you need metrics-based allocation. You track consumption metrics per tenant, maybe database queries executed, CPU consumed on Fargate, or, crucially, the number of LLM tokens used by the CrewAI agents for each tenant's tasks. Then you use these metrics to proportionally divide the total cost of the shared resource among the tenants.
So usage dictates cost allocation. Fair in.
Okay, last big operational piece.
Yeah.
What happens if disaster strikes, like an entire AWS region goes down?
Disaster recovery, DR, and business continuity. Non-negotiable. The first step is defining your targets. RTO, recovery time objective. How quickly do you need to be back up? Maybe 4 hours. And RPO, recovery point objective. How much data can you afford to lose? Maybe 5 minutes? Or for critical data in Aurora global database, maybe near zero, less than a second.
Setting the goals.
Then the strategy. The blueprint favors a pilot-light approach. This means you have a minimal version of your core infrastructure already running in a secondary AWS region. It's not handling traffic, but it's ready. Crucially, your data needs to be replicating continuously to that second region. Services like Aurora Global Database, DynamoDB Global Tables, and S3 cross-region replication handle this.
Data is safe in another region. Correct. Then, if your primary region fails, your automated failover process kicks in. This usually involves Route 53 DNS changes to redirect traffic to the secondary region and using Terraform, or automation scripts, to quickly scale up the pilot-light infrastructure in the DR region to handle the full production load.
And you test this, right?
Absolutely. The blueprint stresses the need for regular DR drills. Running through the failover process periodically is the only way to ensure it actually works when you need it. A DR plan you haven't tested is just a document. Drills find the gaps, ensure the automation works, and train the team. It's critical.
What a comprehensive look. We've gone from the core idea of these collaborating AI agents, this CrewAI, all the way through the robust AWS setup needed to make it secure and scalable, and down to the nitty-gritty of actually running it day-to-day with automation and DR planning. It really hammers home that this kind of platform isn't just giving marketers tools, it's aiming to deliver intelligent, automated outcomes, taking that complexity and hopefully simplifying it through AI.
It really does. And if you sort of zoom out, connect this to the bigger picture, the level of automation we're talking about, driven by these collaborative AI agents, and combined with that really rigorous approach to tenant isolation and security, it does feel like it sets a new benchmark for sophisticated SaaS platforms.
It definitely makes you wonder, doesn't it? How will this ongoing shift towards more autonomous, collaborative AI agents change what you, the listener, expect from software? Not just in marketing tech, but really across any industry in the next few years. What does smart software truly mean going forward?
That is a great question to leave folks with. How might this level of built-in intelligence change the tools you rely on or even the nature of your work? Something to definitely mull over. Thanks for exploring that blueprint with us today. We encourage you to keep thinking about the future of intelligent automation.